Hello, welcome back to my video. Today I'll be doing this question from is a past year from 2005, and then the code is right over here at the bottom. It's also in the title screen, and then you can try this older past year paper by yourself after you have finishing attempting the latest few years ones. And then if you do like a slight comparison, you will realize that the questions in the older past year are usually more tricky and more challenging, and I think it's definitely a good idea to try it out for yourself by yourself. It will definitely boost your confidence in during the exam as well. Okay, so I'm gonna just look at this last, this is actually the last question in the exam paper. So it's an either-or question. You will either choose one of this question to answer, and then I'm gonna try to solve this question for you, which is really similar to the question that I've made in my previous video, but this is slightly more difficult, I would say. And this time, my explanation would take in a different form because I know that actually you guys have like all the basic knowledge for math, so there's probably no need for me to explain every single detail or every single numbers. So I'm gonna just help you to analyze this diagram because I know it's messy right now, but don't worry because I have like another larger copy of diagram for you over there. I'm just gonna help you to analyze this diagram, and by the time I finish explaining the diagram, you should be able to answer all these three questions over here, where two of them ask you to find the length. The parameter is actually basically the also length itself as well. That's including this shaded area and then also the area. Okay, I'm gonna explain the diagram for you now. Okay, we can take this away for now. Okay, first of all, when you see this type of question, the first thing you have to write down is definitely this formula over here. Always put it beside your circle, any diagram or any question that's related to sectors, asking you to calculate areas. Always put this down because usually you can divide the circle, and then you will always see that it's like a pizza, so you will always get some triangle, and then we are actually trying to get some right angle triangle. And then why is it right angle triangle? Because as you can see, if we have any right angle triangle, we can easily solve this question by using these two different formula. Well, this is the Pythagoras theorem in its simplest form, which you may have seen before during your class. And then in this question, it actually is also an application of one of the things that you might have learned in your math class, which is this rule, where if there are two lines stretching out from the center O, this line are obviously equals to each other because they are the radius basically. And then from the point it touches the circumference, and then when they reach down, and then in the case if these two lines that's reaching down are also the same, then we know that this angle is exactly half of this angle over here. So let's say if this here is theta, then here is 2 theta. And then you may have already seen it. You can actually see that this is also basically the radius of this entire circle. So immediately, first you write down, here is also 10 cm. And then as you can see, even though the diagram it says not to scale, but actually you can tell that these two lines are also the same as each other. So in another word, we can straight away write down that if this is delta, then here is 2 delta. And of course, you might also want to write down the formula to calculate the length of a sector and then the area of a sector, which is given over here. But one thing is to bear in mind is that your angle need to be in radian. So we are not given any angle. So if we are going to find any angle, we want our angle to be in radian, and that can be easily done by simply setting your calculator, which I've already demonstrated in my previous video, but I'm just gonna quickly do it again. On your calculator, shift mode press forward, and then you're all set. And then usually when you look at a circle, you might want to get a right angle triangle, because this is the easiest way you can solve or find your angle, because given all this formula. So I'm gonna draw one straight line cutting through this circle right now. Okay, so now we get our right angle triangle. We can put it over here, right angle triangle. We have two right angle triangle now. And then because this entire length is 16 cm, you might want to separately write down that this side is x cm, this side is x cm, and then we have 10 cm over here, and then we don't know the AB, and we also don't know the AD. But at this point, you might already realize that we have a right angle triangle over here, larger one, and also a smaller one on the inside. So you can actually find the length from this AD to O, this length. I'm gonna label a new coordinate over here as F. So how am I supposed to find this length? It's pretty easy, because I'm gonna use the easiest method, which is the hypotenuse over here, the Pythagoras method over here, where it's obvious to us that the longer line A is 10, and then the other shorter one is 8, and then to find the other side, I just have to substitute in, and I'll be able to find the length over here. And then this is how, and by this point, you should be able to solve your first part of the question, which is to show the AD actually, because after you knowing the length over here, you'll be able to solve the length over here, because by knowing the length over here, you can add up the entire length from A down to here, the entire length over here, and then you realize that, actually I've already got two sides of the right angle triangle. All I have to do is to find the remaining one, the other longer side of this right angle triangle. And then this is all you have to do for your part 1. And then for part 2, you are supposed to find the perimeter. Again, the perimeter here, this is the circumference of this circle with radius 10. So easily, after you know the length of this right angle triangle, you might want to try to find the angle using this formula. And then the detail of finding the right angle triangle, of finding the angles, I've written it down, but I want you to try it by yourself first, because if I were to explain in more detail, I would just basically read out all the mathematical calculation, like 2 times what, and then sine times delta equals to opposite divided by adjacent, which I think you will know after I've shown you my working. So all I wanted you to understand is how to read this diagram, and after you know how to read this diagram, how to divide it up, you'll be able to solve it, basically. So I believe the second part is actually not a problem, because I think you can easily tell that in the question, if you read it carefully, these two lines basically the sector of two circles. One circle with radius 10, another circle with radius AB. As you can see here, BD is out of a circle, center A, so BA is obviously the radius for another circle. and then this, all you have to do for perimeter, just to add these two lengths up, utilize this formula. And then before that, you just have to find the angle using the formula over here. Is an application. And then for the last part, for the area, you might want to be more careful. Usually when you find the shaded area over here, you want to look at how you can find it. So you might want to start from that, realizing that this entire sector, is part of our circle, this circle we have over here. And then the seemingly larger one with obviously a larger radius one. So we realize that this is just perhaps the differences between the smaller one and the larger one. So I would say break this part over here into 3 parts. So the first part is the shaded one that you want to find. And then of course, the part is the triangle over here, which we can of course find it easily after you have gotten the length here, because the length here is basically the height of the triangle. So obviously area of the triangle is just base, the 16 times the height that you have found, divided by 2. So you already know this if you have correctly attempted the first part of this question and the second part as well. And then how do we find this? The problem is, how do we find this part? Because if we manage to find this 2 part, we can just easily minus this entire thing by this 2 part, and then we will get our shaded area. So how do we find this 2 part? Again, you realize that this smaller part, BED, this smaller part, is basically this sector from this larger circle with a longer radius. This sector, area of this entire sector minus this larger triangle, BDA, which you can of course find because you also know the length of this entire length, like from here to here. Bear in mind that O to A is also 10 cm, because this is obviously a radius. A radius is that a center point reaching out to any points on the circumference equals to 10 cm. That's why we call it a radius. So after you find the area of this larger triangle, all you have to do is just to minus the area of this sector by the triangle, and then you will get this smaller area. And then all you have to do to obtain the shaded part is to simply use the area of this sector, where this sector is, I'm going to remind you again that this sector is from this smaller circle over here with radius 10, angle 2 delta, and then this sector, and then minus this area of triangle, and then minus this shaded area over here. And then I'm gonna repeat one more time that this area over here is actually part of the sectors that belong to a larger circle with radius AB and with center A with the angle delta minus this triangle. This is how you will attain this smaller part over here. And then after you have gotten this 2 part, you should be able to obtain your shaded area, the area of this shaded region. So I'm going to put up my answer right now. Take a look at the working, because I don't think have to read out every single numerical, like 10 minus x squared, 10 squared minus x squared. I've already written down which formulas I've been using. So you might want to pause the video and take a look at it after you have tried to solve it by yourself. And then you may also realize that I tend to write down the entire expression into my formula because I think they will give me a more accurate answer. But of course, you can choose to round it up to 3 significant figure or 4 significant figure. So this is approximation. So this is the result after I round out, and this is the numbers that I've gotten from the calculator. You may take a look at it, and then, of course, this is the last part. The area